So, who am I? Aly Kafoury, software and data engineer, principal software and data engineer. Been in the field for about 11 years now, professional experience, and I've been writing code since I was 12. So, been a geek and a nerd from the start. Favorite programming language is Rust. Been writing Rust and contributing a bit to the community for some of the current projects. And yeah, what I'm currently doing, I'm building different kinds of platforms for different kinds of industries, telecos, banks, and some SaaS in the middle, SaaS business in the middle. So this is a kind of an intro to platform engineering. I'm trying to be simple about it. So what is platform engineering? It's about solving the problem of operations and giving ownerships to engineers and probably helping them self-serve to like overcome a lot of the difficulties that stems from a lot of things actually. It stems from the cost of operations, it stems from the communication barriers between engineers in remote environments, because that's becoming kind of the norm currently. So the current limitations of the frameworks that we work with, that's DevOps, is the capacity of the capacity of DevOps engineers. They have limited time, they have limited capacity. Engineers, as usual, is an expensive resource to have. So that's one of the things that's causing the current bottleneck in the framework of DevOps. The infrastructure is getting more and more complicated. That's one of the things that's causing the problem, or enhancing the problem actually. You have Kubernetes in the mix, you have GitOps, you have different cloud providers, you have people actually now in bigger situations like Telecos and banks having the requirement of deploying in different continents on different cloud providers. So this is becoming a really big task to handle. One of the other problems that platform engineering hope to solve is ownership. Who owns the environments? Who owns the production environment? Who owns the current testing environments? Should I destroy testing? Can I deploy a new testing branch? Can I approve the cost of this testing operation? And should you, actually? It is.
The AI is taking over.
I think yes. The definition of self-service platforms under which platform engineering tries to achieve its goal is a platform that you don't need to interact with other engineers to do your work in general. So the goal is reducing cost, reducing engineering cost. The goal is helping developers deploy faster. The goal is abstracting a lot of the difficulties that we have in joining this current movement of moving to the cloud, moving to Kubernetes, and lately being Knative, like it's the new trend of deploying stuff. Some of the well-known players that changed the industry was Heroku, that started like ages ago, and it presented a public platform where you can actually just forget about everything, deploy your code, get value instantly. The value here became that people who does not need DevOps engineers, that's the promise of Heroku, that you can deploy without DevOps engineers and you can reduce the operation costs and have your application up and running, start selling without actually like interacting with the infrastructure itself.
So for DevOps engineers, is that a good thing or bad thing?
It's a mix of both, because let's say in bigger environments, you're actually very stressed to go through this. Like imagine a company with 1,000 employees, they all need to deploy something. Engineers on different levels needs to deploy something. You'll find your people ringing, your Slack notifications, your emails off the roof. It's becoming stressful. DevOps engineers are the topmost engineers that burn out in places. They get really exhausted really quickly, even if you're not on call and you have some kind of like ownership management, which platform engineering tries to solve. You still get involved with outages, you still get involved with migrations, a lot of these things. So it tries to relieve the current pressure from engineers to actually machines or code that can solve this. Platform engineering is not a new stuff. that kind of emerged. It's like kind of using the same tools that we have now, but reducing the human element in them. So kinda it's using the same tools. It's using Terraform as a way to manage state or anything like that, CloudFormation, anything to manage state. But you need to have a consistent state in platform engineering. You need to have a goal state that you need to reach. So the tools are currently simple. They are native tools, Terraform, Hellman customized for deploying in Kubernetes and non-Kubernetes deployments. Using GitOps to the fullest, actually. One of the earliest platform engineering ideas was to take GitOps and actually turn Git itself into a platform. So whatever you have in Git is actually the infrastructure. So when you move to that, developers, whatever backend, front-end developers, can have some kind of code that they have in the master branch or whatever branch they're working to deploy, and then in the end, that what lands up in production. What platform engineering does is ties tools together. Like a simple example of that most DevOps have went through. You provision an infrastructure, so Terraform. Now you want to provision the EC2 instances. You take the output from Terraform, you add it to Ansible. Ansible starts doing stuff. You take the output from Ansible, you add it to another tool, and you start doing stuff. So a kind of tool chaining to be fit. What mostly platform engineers aspire to is having some kind of interface or some kind of tool that abstracts most of this and allows engineers to deploy more easily. I know it's a bit abstract now, but in case studies, it will become really clear what I mean about that. I have currently more than 4 clients that I'm consulting for. They are all building platforms, internal platforms. One of them is a telco provider, a very big telco provider. What is a platform looks like for a telco provider? A platform for a telco provider is an interface at which third-party providers, let that be hardware or software, can deploy their tools on their infrastructure. So let's say this telco provider has a tower, a 5G tower. There comes a third party, installs a new hardware tool, and needs to deploy the software to manage that. So what we were building for that telco provider is actually a UI that you can log in through, add in the package that you want to deploy on the infrastructure on 5G edge towers, and then that gets deployed. For them, that's the perfect platform that solves most of their problems. Because later you had to call a DevOps engineer, had to go to log into the tower and then start deploying their stuff, debugging the deployment actually, and doing all of that. So one of the examples of where the cost of like building a platform really outweighed the cost of having engineers on site or doing that. One of the other case studies that was actually very strong was actually platform engineering for a bank. Deploying something through a bank, change control is extremely hard. Like you have to go through the following steps. You have to go through QA and testing, then you have to go through security testing, you have to go through business testing and business approval, all of that, and then you get to deploy the stuff. So imagine you having to do this through communication, phone calls, emails, Slacking, whatever, and the time that it was wasted doing that. So one of the tools that platform engineering allowed us to go through this hassle. You go in, you create a deployment, a window opens up for security engineering that they take this new deployment, they test it, they attach a report to it, they submit it, a new window opens up for business management. Business management can actually take that and approve that through another management or consulting or lawyers and legal. And all of this used to be done by emails and Slacks. It would take like a month to just deploy. Now it takes around 2 days to deploy a new deployment.
Okay, so how far do DevOps care about business approval? Is it an integral, essential part of DevOps?
There is no part of engineering that does not care about business approval. If you're not serving the business, it doesn't mean anything. Like if you're not adding value, if you're not adding cost, removing cost, if you're not helping the business somehow. If you're not increasing sales, what you're doing is pointless. You have in all situation to serve the business. That's it.
The idea is I hear about biz DevOps, and I thought that's a separate workflow.
I think it might be a hype or something like that, because if you're not like serving the business, it's actually pointless. Even in big enterprises where they can throw money at problems, they don't actually do that. That everything in engineering needs to be approved by the business side. Another test case is SaaS platforms. A very specific SaaS that I was working with, we had around 25 deployments per day. These deployments were being done through Terraform, and it was very complicated because they need to run bash scripts that deploys Terraform, renders Terraform, and actually starts calling third-party APIs to confirm the deployment, the reconnect, generate new API keys, and do all of this stuff. Now, since this operation can all be like automated, most of this is being run through a platform. A platform actually does the API calls, renders your Terraform, applies your Terraform, tells you if a deployment fails. They actually have a QTUI which tells you which deployment perform best on the business side, so that you can even roll back as a feature or as a deployment to a deployment that actually mattered or was very efficient.
Ali, I have a question about the last case study. Should I ask it now or like at the end?
Go ahead.
Okay, so like in environments that they leverage Terraform, what complexities are it? I mean, what made it difficult?
The extensibility of Terraform, a bit deeper into that problem itself, we had to write a custom provider for Terraform to stay into the Terraform business. Like, we had two options, either leave Terraform or add a provider that as actually a wrapper around our provider that provides API calls that we can do to other third parties, provided the ability to do some bash scripts and some maintenance scripts. So it's actually the limitations of the current ecosystem by Terraform itself. So Terraform wants to maintain a state and only state. Like I talked to actually HashiCorp engineers from about 2 or 3 weeks, and the answer was this: it's getting too complicated. We don't want to do anything other than manage state. Where in reality, you always have to do migrations, database migrations. If you plug a new version, you always have to do database migrations. You're talking to third-party providers, whatever they are, cloud providers, whatever, you're sending SMS messages. You're doing everything has a third-party provider that you talk to. So there is no deployments without talking to APIs. That's very old school. Terraform doesn't want to do that because of the complexities. Where do I store the response of something like an API call that's coming from a third-party provider? Should I fail if something responds badly? How can I accept or approve the state currently? Or how can I, if you reply this, how can I make it replicatable? Does the API allow this or not? So because of the difficulties they see, you don't want to approach this or make this approach specifically, but in reality, that's needed, that's always needed. You can do anything regarding SaaS without it. Since this is an intro, what resumes do we look for in platform engineers? So we mostly look for people who are self-starters, have something on GitHub actually to show they take the extra step. When you join as a platform engineer, most people would not know what to improve. So every input is valuable. So seeing that you're playing with current technologies, you're doing your own projects actually matters. The knowledge is very broad when it comes to platform engineering. We look for people who knows how everything works. They don't have to be good at it, but you know how the front end works, you know how the back end works. You're not afraid to dabble with those areas if needed, because probably all platforms would need a back end and a front end. Extremely simple ones, most of the stuff they do, they take input and render it, but you should be able to do this stuff. Interest in new technologies, that's like a given, because when you see the state of LinkedIn now, everyone talks AI is gonna replace your job, it's gonna take your place, and actually that's not. Like, my study is in engineering statistics, so I know that AI is just big language models currently that does some kind of statistics to generate the answers that we need.
Someone had a very nice comment where he says, for AI, we need to provide it with a clear description of the engineering problem, so we are safe.
Currently, yes, AI is just some language model that use statistics to generate that. So if you actually understand, AI is a great technology. If you actually understand how to use that efficiently, it's something that we look for. If I talk to someone it's not in our field of business, but if you know what's AI, you're interested in new technology, and you actually know what it does, you're probably gonna be a good platform engineer. Cost management, the mentality of that, what I'm doing in engineering is actually affecting the cost, affecting the business that I'm working on. So whenever a new or an interview, I talk to someone and it becomes very ambitious regarding technology. I want to deploy everything Knative, and I want to have 10 Kubernetes clusters, and let's do cluster mesh between them, and let's do everything. And I say, but then cost. What do we do about cost? So you need to be very cautious about this. We do platform engineering because we think that doing it now is better than doing it manual 100 times more. So we're actually reducing the time, we're reducing complexity, we're abstracting it, all of this for the sake of reducing the cost of operations. So probably that's it. Any questions is welcome. Go ahead.
So like if I'm working in an organization and we're growing, when is the right time to start thinking about like we should do platform engineering? So like some companies say 50 engineers, some companies 30, and some companies actually say we should start from the beginning. So like, what do you think?
Starting from a beginning is a total overkill. When you start a company, you need to validate your business on the idea, you need to make some sales, you need to actually start growing the business, you need to be valid. Like I was reading an excellent article about SiloDB. They actually started as an OS company, they wanted to do their own OS, and then they found that Docker came out and the idea became invalid. So they moved into databases because they know everything about how low-level stuff works, so they reuse their knowledge to make a database. So the pivoting is everything in starting a new business, and building a solid platform, investing in a platform when you start that doesn't make any sense. So you should start a platform whenever you have too much production features than DevOps engineers, whenever that happens. Like you want to deploy 25 times, but I don't have 25 engineers and I can't.
So can we measure it by the support ticket throughput, for example? Like how can we find this out?
Mostly this, when I talk to organizations that want to build platforms, and I ask why, that's one of the extremely important questions, why? Because we're doing mundane work currently, we're doing repetitive work. We have a framework that we understood makes the business successful. We want to deploy like every weekend, and it's becoming mundane, but we definitely know what we need. So if you're still looking for product market fit, if you're a one-person team, but you have found product market fit, you're doing great sales, you're doing everything, it's really great to automate your deployments with a click. That's the dream about it. I hope I've answered a good enough answer. Any other questions?
So you're saying you have a platform. When would I need to switch from Heroku to actually Kubernetes? What would trigger you to leave Heroku and have a, like in another way, why is Heroku not enough?
I have
I have my own version, of course, but I mean, like I want to see how you think about it.
I have a dear engineer who works in Google. He's one of the Ruby contributors. We actually debated this very strongly. Okay. He was like, he had like 20 or 30 offers to go work for Heroku because Heroku started as a Ruby shop to deploy this. The performance per cost is something that becomes extremely like cautious about. What value does Heroku provide you when you pay your dollars? Like
not hiring platform engineers.
No.
That is the value. The salaries of all those engineers will not be paid.
The salaries, it's extremely a good point, but it comes down to this. when managing Heroku becomes a headache, that actually happens. Scaling up, that's actually an extremely bad thing about Heroku and how it scales, or the efficiency of scaling in Heroku. That's something that we discussed. Storage databases, when you need to connect to other services that Heroku doesn't provide or provides a very custom version of, like Elasticsearch, Postgres databases. Managed databases on Heroku is becoming extremely expensive lately. So connecting
It's actually
to a database.
obvious. Yeah.
It's actually obvious, yes. So they are overpricing the EC2 instances, which is actually extremely overpriced. So cost-wise, it becomes actually very inefficient whenever you reach a specific state of growth. So that's the reality. Heroku provides really good value whenever you're small, whenever you're mid-size, whenever you start getting requests, it becomes a headache. Like I moved one company from Heroku to AWS, not for Kubernetes specifically, but because it was getting pretty annoying for the dynos to start to speak to the other ports and calling the APIs. It's doing a lot of round trips, external round trips through the internet. So the cost is ranking up, the performance is degrading. It's actually really well made if you're deploying one instance of a monolith that will run, and then that's it.
Okay. That's not my. I had to move out of Heroku with tears in my eyes.
Why?
Well, I would love to know.
Maybe, but not because of the reasons as he said. Because even I scaled even another company, and in trade we had absolutely was not about performance.
Mm-hmm.
When we needed a very strong security zone,
Yeah, then you have to pay 250.
then no, it's not a matter of cost. I was happy with the cost.
You want to pause
I
the
was
soft
happy with the
compliance.
cost. I don't want to all the Kubernetes manifest and the crap. I don't want that. I really don't want that.
I was talking to Georgia.
That's a waste of life.
Yeah,
But
I was.
I had to, like, once I started needing one secure perimeter zone with everything inside, it became very hard.
SOC compliance.
Like when I started compliance, and the dynos, even the solutions there that are given by the private spaces and so on, were a bit there. But I didn't move due to cost or speed.
But why do the private spaces were not enough? I mean,
Like we needed to have all the S3, we wanted to define security zones, the database for it not to be public was a hassle. It was always security. It was, for me, I mean, in our space, it was not the cost or the...
It was GPDR or SOC compliance?
No, even before that.
GPDR requires that your data, actually, the European Union data does not leave the...
But I can choose my zone.
Yeah. But
Right?
it wants that secure data, not
Yeah.
even that, does not interact with the public internet. So that's not available.
Okay.
But I never knew the client or the customer. Any other questions about getting into platform engineering or the current movements of platform engineering in general? Go ahead.
I have a question. So given that the trend now is moving out of serverless and going back to
it's not a trend.
It's a bit of hype. Like in general, how does the architecture of the app or the software affect your view as a platform engineer, or how does it go into the process of designing a platform?
Yes, actually, you need to be part of the product as much as any engineer. The problem with the current state of DevOps is dev and ops, and they're still dev and ops. Like, you find engineers don't care about what happens in production, and that's where ownership comes. You want everyone is involved with deployments when they happen and how they happen, and actually own the problems. Like when something breaks down on production, you need to intervene with that as a platform engineer and as a developer who actually created that, because you'll probably be seeing stuff in the logs that I know nothing about, so I would probably need your help to decipher this. So the architecture of the application tells me everything where I need to deploy my platform, how do I need to deploy it, what features do I need to integrate. Like for Telecos, they are starting to move towards serverless actually because of a very huge amount of third-party providers, and instead of deploying well-run or let's say pods that eat resources without actually doing anything, we are moving to the functions. So everything is a function. I want all my third-party providers to only provide me a function that will run and exit. I don't want it to eat infrastructure resources. So Telecos are moving to Knative, are moving to trigger mesh, technologies that shift serverless inside of Kubernetes because of cost, because of Amazon Lambda is actually pretty costly, and because of some stuff that needs to be deployed on premises anyway. Any other questions?
Curious, I understand you need Python and Go in platform engineering. Which areas of platform engineering do you use Rust in?
Firecracker. Firecracker is an amazing.
That's if you're contributing on the virtualization technology itself.
No, and if you're building a plugin for it.
Or WebAssembly,
Okay.
because
Yeah.
like WebAssembly is at the edge.
WebAssembly, yes.
Deployment is not a thing.
But WASM isn't. Okay, educate me. How is WASM platform engineering?
So some people actually are working on, like in the CNCF Foundation, are working on projects to make you deploy microservices as WebAssembly code that executes on edge.
So they're deploying WASM in
So
the
instead of
backend?
using containers, you
Yes,
just
yeah.
deploy WASM.
And instead of containers, yes.
That's crazy. But
Okay, fine. So it's very esoteric. Okay, fine.
I see the academic background is.
Cloudflare workers.
Yeah, Cloudflare workers is one of them.
So if you want to run code that's on the edge, for instance, like in your
Yeah,
CDN,
that I get. Yeah,
because that's one example.
on the browsers.
No, the edge is the edge locations of the
But I mean,
CDN.
WASM was created for the browser.
yeah, but now
Yeah.
it took it in very different.
They are trying to replace containers basically with WASM really. Because actually, if you think about it, it makes some sense. You don't need the whole hassle of the containerization layer. You were happy with Heroku. It takes us back to Heroku actually.
Okay. Cool.
Anything else I can answer? Thank you.
Thank you.